Hi everyone, it's Evan. This is part 2 of the Interface A video that I made part 1 of back 5 months ago. Sorry it took so long for the sequel. I had Brick World Chicago and then Brick Fair Virginia in the middle, keeping me busy. So I explained in part 1 all about my favorite Lego piece, Interface A 9750. And so now we're going to show you how it actually works in BASIC on the 4 main computers it was meant for: the Apple II, the BBC Micro, the Commodore 64, and the IBM PC. The Apple II and the IBM PC require a special card that goes in the computer that Lego produced. And the BBC Micro, which is a straight through ordinary ribbon cable, nothing special about it whatsoever. You can get that anywhere. And on the Commodore, it's an ordinary cable on one end, but a special Commodore user port connector on the other end. And all the part numbers and details about that are available on the connections page on my website, brickhacks.com. So, that's a quick reminder of how the box works. So as I mentioned briefly in the previous video, you have 6 outputs and 2 inputs. The outputs are for 4.5 volt lights and motors. The inputs are for 4.5 volt touch and optical sensors. You count them up in decimal encoded binary from 0 to 7. Port 0 to port 7, it's 1, 2, 4, 8, 16, 32, 64, and 128. Everything will be 255, of course. Now we're going to show you how to program those. So we'll begin with the Apple II. First thing you do on the Apple II is run the Lego initialization code, which tells the card which bits are outputs, which bits are inputs. This is the code starting line 20. I happen to have S equals 4. S could be any slot number you want, 1 through 7 on the Apple II. And then L equals 49280 plus S times 16. Poke L plus 3, 1. Poke L plus 2, 63. And poke L plus 1, 0. L could be anything you want for a variable. L for Lego is nice and easy. And you can do this all on one line with colons. You can make it a subroutine, whatever you like. But your programs must begin with it. So I run that, and now our card is initialized in the computer, ready to go. Okay, everything's off. So we just do peek and poke. I already described how it's 1, 2, 4, 8, 16, 32. Poke L, 1, that goes on. Poke L, 2, that goes on. Poke L, 3, they both go on. And so on, up in decimal encoded binary. To peek, remember we have 64 or 128. We can do, say, 100, x equals peek L, 110, print x, and 120 go to 100. Run that again. Now it's on 3 because these two are still on, right? So we'll fix that. L, 0, run it. Now it sees nothing, nothing's turned on. If we press this button on a touch sensor, that'll become 64 and light 6 will go on. If I were to do the same thing on port 7, well, I'll show you. It'll become 128. And if sensors were both on, there would be 192. But remember, when you program, you have to account for whatever else may also be on. So that's how I do it on the Apple II. So now we're going to do basically the same thing on the BBC Micro, except there's no card, there's just a cable, as I discussed earlier. And this time, the initialization code is something you just have to kind of know by yourself in BBC Basic. Question mark ampersand FE62 equals 63. And that'll set the output, first 6 bits outputs, and the latter 2 is inputs. Then, question mark ampersand FE60 is basically the same as poke to any value you want. So 63 will be all of them on. And I'll turn the tripod a little bit. Oh, actually, I'll move this up here so you can see it. Hopefully you can see that. You can't see that. I'll have to zoom out here a little bit for you. tripod down a bit. All right. So now you can see all the lights are on. 63 is all on. Question mark, ampersand. Oh, it's falling down. Sorry about that. FE 60 equals, say, 4. And now number 2 is on. Etc. Similar peaking process. We can do X. We can do, let's see here, 10, question mark, ampersand, FE 62 equals 63. And then we could do 20, X equals, question mark, ampersand, FE 60, 30, print X, and 40, go to 20. Now it's going to say 0. I'm sorry, 4, because that's still on, right? And I'll take my touch sensor and I'll put it in number 6. And you'll see if I press the button, it changes. Boom, jumps to 68 and back to 4. Because it's 64 and 4. So that's it on the BBC Micro. Okay, here we are on the Commodore 64. You might see a little reflection from the light above me on the screen. Sorry about that. So we'll start with, just like on a BBC, except it's peek and poke, as opposed to those weird question mark ampersand commands. So first we start with poke 56579, comma 63. There is an issue with my monitor changing colors now and then. Sorry about that. So that sets, again, the outputs first 6, the inputs last 2. So 56579, comma 63 is the command. And then poke 56577 is your normal poke. So 63 will be off and on. And just like the other computers, 56577, comma 1, and start counting up just like all the other ones. Again, I'm sorry for the weird video quality here and the color changes. Peak is going to be similar. Plug it into port 7 this time. Touch sensor. We can do 10, poke 56579, comma 63, 20, X equals forgot something. We'll do L equals 56577, 30, X equals peak L, and 40 print X, and 50 go to 30. Run that. It's 1 because that's still on. And here we'll have 129. And that's the example on the Commodore. And finally, the IBM PC MS-DOS computer. This is the only one that doesn't have BASIC and ROM. Well, technically it does, but we're booting off a floppy disk in DOS. So we're going to go into BASIC. Now in this one, you also have a card like on the Apple, but there's no real initialization code. All you got to do is set the memory address. By default, it's 925. There's a little metal address wire on the card you can cut. By doing so, it changes it to 926. Therefore, you could have 2 cards in one computer. And that's documented in the Lego manual. So we'll say L equals 925. I'll put caps lock on, make it easier to read. And then instead of peek and poke, it's just out and imp. Nice and easy. Out, L comma 63. Everything goes on. Out, L comma 0. Everything goes off. Out, L comma 1. Out, L comma 2. Out, L comma 3, and so on. In some ways, that makes the IBM PC the easiest to program out of all of them. IMP will be, let's see, a little program as usual. We'll say to line 10, L equals 925. Line 20, we'll say X equals, not peak, but I'm used to that as a habit because I use the Apple II most of the time. Imp L, line 30, print X, and line 40, go to 20, and we'll run that. It'll be 3 because those two are on already. We'll say 64 here. Press the button, and 3 becomes 67. Back to 3, 67, etc. That's it for the IBM PC.